Next type of graph we're going to look at is the truncus, and it's the graph of 1 over x squared, or x to the power of -2. And the general shape of the graph is this, similar to the hyperbola, but this time we have no negative values for y, because as you appreciate, whatever number you've got here in the denominator, whether it be positive or negative, now we're always going to be squaring it. So if x is -3, we get 1 over 9. If x was positive 3, we'd also get 1 over 9. So whatever number you put in as x there in the denominator, positive or negative, we're always going to end up with a positive answer. So that's why the range of this graph, as you can see, is the real numbers, positive real numbers, sorry. Okay, so you could say that y is the positive real numbers, would be the range of this graph. The domain, okay, would be all the real numbers, okay, bar 0, okay, because the graph is not defined at x equals 0, because you can't divide 1 by 0. So it's asymptotic once again. You can see there's a horizontal asymptote at y equals 0, and there's a vertical asymptote at x equals 0. So that's the general shape there, that blue graph of 1 over x squared. And as we had with our previous graphs, we've got dilations. The red graph there is the graph of 2 over x squared. Okay, so the y values would effectively be doubled. So here on 1 over x squared we've got the 0.11, but on y equals 2 over x squared we've got the 0.12. Here on the original graph we've got the 0.1 comma a half, and here on the graph of 2 over x squared we've got the point, got the point there, 2 comma 1. So any x value you can think of, the graph is dilated by a factor of 2. From the x-axis. Alright, reflections. Okay, if we've got -1 over x squared, of course that makes all our y values negative, so it's going to reflect it in the x-axis. So the points 1, 1 becomes 1, -1, so it's reflected down there in the x-axis. So that's the graph of -1 over x squared. Reflections in the y-axis. So we've got this orange graph here, which would be 1 over x minus 3 squared, and notice how a -3 in the denominator inside the bracket that is squared. It moves the original shape of the graph 3 places to the right. Okay, and if we had -x take 3, that would reflect the orange graph in the y-axis. So we'd get the blue graph there with a vertical asymptote at x equals -3. That's reflection in the y-axis. Okay, we've also got our translations up and down. Okay, and we can see if we've got 1 over x squared plus 2, that plus 2 over there has taken the graph up 2 units. So the horizontal asymptote is now y equals 2 instead of y equals 0. And then we've got a combination of transformations. Y equals a over x minus b squared plus c. So you have a shift there, b units to the right, c units up. So our asymptotes would change from the axes to y equals c and x equals b. And we've got our graph up there on the top right hand corner. So that's a combination of transformations you can have with the truncus. What would we have here? Well, we've got -1 over x minus 2 squared. We've got a 1 up the top there, so there's no dilations, so we go straight to reflections, and that -1 there would mean there'd be a reflection in the x-axis. The -2 there means it's translated 2 units to the right. -1 over here means that it's translated 1 unit down. Okay, so that would be the transformations we'd make to the graph of y equals 1 over x squared to form that graph there. What about this one? What would be the equations of the asymptotes, the domain and the range? Well, with this one, first thing I look at doing here is just changing it a little bit. Sometimes the 3 plus x thing confuses people, but all it really is the same as 3 plus x. X plus 3. So they are the same thing, so that looks more familiar to us. So the equations of the asymptotes, okay, if I just drew a quick sketch of that graph, oops, I just drew a quick sketch of that graph. There's our axes. Put in our asymptotes. The plus 3 would take it 3 places to the left. The minus 4 would take it 4 places down. Our 2 would be a dilation by a factor of 2. So that would be our basic shape of the graph. Oh, sorry, that's where our axes would be. So our basic shape of the graph would be something like this and something like this. Okay. Equations of the asymptotes. Okay, this one would be y equals -4. That's the horizontal asymptote. Vertical asymptote would be x equals -3. The domain, x would be, the real numbers except for -3. And for the range, that y would be the real numbers except for -4. Actually, sorry, do back a step. No, it wouldn't be. It would be the, in fact, I might just write this in a different form. Because the range, I was thinking hyperbola there, but the range do not go below -4. So you could say the range was y is greater than -4. Notice down here, down below, there are no, well, the graph isn't defined there. Okay, it's only defined above y equals -4. Okay, sketch the graph of 2 minus 1 over x plus 1 squared. Let's just draw a quick sketch of what it might look like. And before we go and find all our key points, so put in some asymptotes as well. So asymptotes are going to be -1. It's been moved 1 place to the left. And it's been moved 2 places up. Remember that this can also be written, it's sometimes handy to do this, y equals negative over x plus 1 squared plus 2. So you can quite clearly see there it's been moved up 2 places. So we've got asymptote at 2 and asymptote here at -1. So the graph is going to be up here and up here. Now why is that handy to do that? I haven't drawn that very well, but I can see straight away, in fact no it's not, let's just go back a step, because I've forgotten that we've got -1 on the top there, so it's actually going to be reflected in the x-axis. So it's going to be here and here. So that might give us a rough guide as to where our intercepts might be. Let's go ahead now and find the intercepts. And we'll find the y-intercept first by making x equals 0. 2 minus 1 over 0 plus 1 squared equals 2 minus 1 over 1 equals 1. So the y-intercept is going to be 0, 1. And if we go back to our rough sketch here, that point there is going to be 1. Our x-intercept, we're going to get 0 equals 2 minus 1 over x plus 1 squared. Actually going to take that bit there and take it on the other side, so it becomes positive 1 over x plus 1 squared equals 2. So 1 will equal 2 outside of x plus 1 all squared. So now if we go and remove the brackets, 2x plus 1 equals 2x squared plus 4x plus 2 by removing the brackets there. So we get 2x squared plus 4x plus 1 equaling 0. Okay, so we've got 2x squared plus 4x plus 1 equals 0. And that doesn't factorise, so we've got to use the quadratic formula. So a equals 2, b equals 4, and c equals 1. So x will be negative b, plus or minus the square root of b squared, which is 4 squared, minus 4 times 2, which is a, times 1, which is c. So that's negative 4 plus or minus the square root of 16 minus 8. Actually, just a moment, I've got to forgot about the over 2a here. So let's put that over 2a, so that's over 2 times 2. So that's negative 4 plus or minus the square root of 8 over 4 equals negative 4 plus or minus the square root of, square root of 8 is 2 root 2 over 4. And that's going to equal negative 2 plus or minus the square root of 2 over 2. So we've got two answers there. Okay, so if we work it out in the calculator, we get negative 0.3 and 1.7. So they are the two x-intercepts. So I go back to the graph. So we've got negative 1.7 over here, and the point there is negative 0.3. Next question. We need to find this equation. Okay, and to do that, we look at the general form, which is a over x minus b squared plus c. Now you can see that we've got a reflection of the x-axis. So straight away we know that that value of a, when we find it's going to be a negative number. So let's have a look what we've got. We've got y equals a over x minus 2 squared. Why is it x minus 2 squared? Because it's been shifted 2 places to the right. And we can see that there is no plus c, because the asymptote is still on the x-axis there. So we've only had a shift to the right. So and the shift to the right is 2 places. Now we've got this point here. We've got a y-intercept of negative a half 0. So we're going to use 0 negative a half, 0 negative a half to help us find out this graph. So we're going to use that point. Okay, 0 negative a half. Let's get rid of that. So 0 negative a half. So we know that if y equals 0, we know that negative a half equals a over 0 minus 2 squared. And I've substituted in x equals 0 there. Okay, so negative a half equals a over 4. So that means that if we multiply through by 4, negative 4 on 2 equals a, and it means a equals negative 2. So our equation is going to be negative 2 over x minus 2 squared. So that's going to be our equation. Y equals that. And there's no up and down shifts. There's no c out here anywhere. And as we predicted, our value of a was negative. So that gets us a start with the truncus. So you can now have a go at exercise 2D.